Assalamualaikum and greetings. First of all, I would like to introduce myself. My name is Muhammad Faiz bin Akmal. I am a representative from Group 6, Section 4. Today, I will be presenting a pre-recorded video on our structure and 3D design of the robot arm. Okay, as you can see right now, this is the an overall view of our robot arm. So throughout this presentation, there will be two parts of this video. The first part is I will be explaining about the structure and components that we have used on our robot arm. And the next part or the last part, I will show or simulates the movement of the robot arm itself. So let's go to the first part of this video. And before that, I would like to have a better view of the structure. Okay, I think here is good enough. Um, uh, about the structure of the robot arm, uh, in the making process, we divide the structure into two groups, which is the first part here, as I point out with my cursor here in this area. This is the main body, and then the second group is here, which is the robotic arm itself. So at the first place, let's go into the main body first. Okay, I think this is good enough. um, Talking about the components, the first thing that I would like to present is the wheels. We choose to have two wheels at the back, and each of the wheels are powered by a DC motor, and the DC motor can be controlled by the user, where the program have been installed into the microcontroller, etc., so that the motor can rotate. Each of the motor can rotates at different speeds in a time, so that this robot arm can maneuver in any direction as the uh, user input any direction that he wanted to go. And then this DC motor also can rotate in either direction, which can make the robot arm to move forward or backwards. And then the next component is the caster wheel at the front. The main purpose of this caster wheel is to support the load at the front of the structure. Uh, and then it also can rotate freely 360 in any direction, so that it can follow the moving direction of the rear wheels. The next component is the power supply. For this project, we have decided to use two 9 volts battery, and we place it at the back of the structure. We decide to do so because battery have some wicks on it, so we think it is an advantage to put some counterweight at the back to void from the whole structure tilting forward when lifting some heavy objects. And next, why we think we need a two power supply? This is because if we just solely depends on the power supply from the Arduino Uno chips itself, uh, it is not sufficient in order to provide power for 4 servo motor and 2 high RPM DC motor, which the battery will drain quickly, so it is not convenient for us. Moving on to the next component, which is the Arduino board itself, the controller for the whole system. And then we have the breadboard top here at the top. This is the for the electrical circuit, which will be explained in the next part of the video. And then for the structural components, we have the base plate to hold all of the components such as the DC motor, caster wheel, Arduino board, and batteries. And then we have four pillars to provide some space or gap for the batteries and Arduino. And then we have the top board where we'll hold the whole structure of the arm, and then for the placement of the breadboard. So that's all for the main body. Moving on to the robot arm, or to the robotic arm. So this is the whole structure of the robotic arm. It consists of 4 servo motors, as you can see here. And this is the first servo motor. This is the second one, third one, and fourth one. This numbering is important because in the next section, where one of my colleagues explaining about the control system, there will be 4 potentiometers, and each of those will control each of these servo motors. So it's better to have an understanding which one is which. And then in this robotic arm, there are 4 main parts, which is the first one here. This is the arm rotator. The next one here, this is the long arm, because obviously it is the longest arm in this robotic arm. And the next one we have the short arm, and the last one we have the grabber. The arm rotator will function to rotate the whole structure. If we have a view from the rear of this device, this arm rotator will make the arm to rotate in the left or right direction. And then the long arm are purposely to control the elevation of the grabber and the short arm. The short arm is just like the longer arm, but it's more focused on moving the grabber. And the last one, which is the grabber, to grab on objects and place it in another place. So that's all for the structure and the device that we have used on our robot arm. So on the next part, I will go on to show the simulation and the moving motion of the robotic arm. Okay, I think it is here. So at the beginning of the next section, it will start by simulate the moving motion of the grabber itself, and then the video will show the moving motion of the arm and also the arm rotator. So that is the preview of the moving motion of the robot arm. I think that's all for this presentation. However, there is another part another part of the video where one of my colleagues will explain more details about the electrical circuit of this robotic arm. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Syahid Fahmi bin Muhammad Afandi, and I am in charge in designing the circuit board for our project. So first of all, this video is the purpose of this video is to show the simulation of how our circuit is working. And before that, I would like to introduce a few of crucial components, which is motor driver, L293D, DC motor, servo motor, Arduino, and of course our 9V battery, and one more 5V regulator voltage. So about this component, what is 5V regulator voltage? This component is to make sure the voltage input is to be stepped down, so that the whole circuit will use the amount of voltage of 5V. This is to ensure that our motor driver will not overheated, because the weakness of the motor driver is if this motor driver is overheated, then it will go, or we can say it will fail. And this motor driver will control the output of the DC motor, which is later we'll see in the simulation. And Arduino, we use Arduino Uno for our project because Arduino is much easier compared to other microprocessor in term of what we call in term of coding the microprocessor itself. And for the servo, we use servo for robotic arm mechanism, which is servo 1 at for joint 1, servo 2 for joint 2, servo 3 and 4 for robotic claw. And the wheel steering, this potentiometer is used to control the speed and the direction of our DC motor, and this potentiometer to control the movement of our servo. Simple, I can say servo 1 to move along X direction if there is given 3 axes, X, Y and Z. So servo 1 will move along X axis, servo 2 will move along Y axis, and servo 4 and servo 3 will control the open close claw. So let's move to our simulation. And before we start, we have to push these 2 push button first, 1, 2, and then there is 0 RPM plate. And if we want to allow the speed, we have to switch off this slide switch, and we can see 243 RPM and this 0 RPM. Why? Because of this steering effect. If we control the steering effect, and hence there is speed here, but speed here will be reduced. And same goes if I move to this maximum, speed for the left wheel will undergoes the maximum speed, while the right wheel will undergoes almost 0 RPM. And the wheel speed, of course, the speed of the motor we can control. Look at that, from 0, then I move to the maximum. From here 0, here 243. And for the servo, if I move to this one, and servo 2 will move. You can see that there is some bug here because it should servo 1, servo 4, servo 3 and servo 1 should not be moving. I don't know why, but I might say that this kind of bug. And servo 1 we can control also by adjusting our potentiometer, and servo 1 will be moved same direction as servo 2, servo 3 and servo 4. So how can we determine the direction of our robot, of our tire, which give the forward move or backward move? By these two push button. If I push this top button, and it will go for positive RPM, which mean negative RPM, which mean our tire move anti-clockwise and our robot will move forward, and reverse vice versa. So let's see. First I have to turn off this one and turn on this one. It will give negative RPM. Right. But the red button give the meaning our robot is moved backward. If I close this one and I open this one, it might be some mistake or bug, because before this I have tried and there is no error at all. Let's try it again. Positive, forward, yeah, there it goes, negative RPM. I'm sorry because my laptop cannot support much RPM, therefore it will be much lagging, if you can see. So that's all for our simulation. Thank you.